It will start modulating on the EV. Yes. Oh, yes. I was a bit nervous. Of course it works, I did it. We have an alarm. Good. High temperature. That's because it's at 7 degrees. And our set point is minus 18. So as far as I remember, I might have an issue with this. Let's go. We have some issues. There we go. Right, so this one, I need to adjust it, but I don't think it will go low enough. I need to put an offset. So yeah, the type of potentiometer I used, it goes up to minus 12. So, but there's a way around it. I will put an offset on the calibration, which I should have done it earlier. So there you are, OS1. I'll put this as minus 10. Will that work? Get it to read minus 22. I'll put it minus 11. Put the same to nothing. Yes, it worked. I'll put the same offset to this one. Yeah, there we go. Minus 23. So minus 22. Minus 20. 18, 17, 16, 15. There we go. Just want to raise that bit because it will go into an alarm. Come on, up, down, sorry. There we are. T2 minus 12. Ah, yeah. Let's leave it at, no, actually. Let's just go low with this. The evaporator probe, because the compressor was running, she says reading minus 23, 24. Okay. So as you can see, it's got delay. Yeah, it reached set point. It does not want to bring the compressor because the parameter compressor rest time, CRT, is set at 2 minutes. So let's change this so we can play around with it and see what it does. CRT, I'm gonna change this to 0. There we go. So I'm changing it just to run some tests. In real life, I wouldn't change it unless I was running tests. Maybe, depends. Right, so it brought compressor number 1. It brought also compressor number 2 because it's got the timer relay. That's good. Let's open the door. Yes. So I opened the door. It stopped everything, especially if it's a freezer. That's good. We close the door. It will start running. There's a delay before it brings the evaporator fan, which is normal. Let's press good. Brought in the evaporator fan. Let's see if it trips on high pressure. HP. However, this is just an alarm. If you've got the safety circuit on an actual fridge, these would be wires to stop the compressor. But this one, it just recognizes there's an alarm and that's it. So yeah, you will see that this one, the Danfoss one, when I'll make a video about it, if I trip that, it will show an alarm. Actually, I can do this right now. Let's do it quickly. Let's just do it quickly. So there's just, right, so it's working. It will start modulating on the EV. Yes. Oh, yes. Go, baby. Okay, so this is my cold room door switch. Yes, it stops. Comes back in. And if it were, I'm gonna make this strip my oil management. It's all a daisy chain anyway, so it doesn't really matter. Let's see if this one recognizes the safety circuit trip, and it will also stop the compressor. Should do. Yes. Ooh, I'm good. And it will even show me a trip on the light. I was a bit nervous. Of course it works. I did it. Come on, stay there. Okay, so we just prove that. Let's just use stop. You just put this back. It does not want to stay in properly, does it? Okay. Stay there. No. You stay. Good. Let's try this one now. Coming back to this. Right, so let's just... this controller now is running on the first group of its set point. But there's a second group, which we set it to run at minus 22 IISP. Yeah, minus 22. So let's, because now it's running at minus 18. So let's switch this into the second group, and I think it's this one. Yes. So now my set point is minus 22. So I switched the second group of the set point. Okay. So now if my temperature is reading minus 22, minus 18, you should ignore that. It does. And then temperature will keep getting lower and lower. It will get to minus 22. It will stop. Okay. Then the temperature will start dropping. And yes, here we go. It brought the compressor again. Yeah, it brought it straight away is because, as I said earlier, we got rid, just for our test purposes, of the compressor rest time, CRT. However, this control will allow you to put a switch where the customer can physically go like this or like that and switch it between the two groups of set points. So let's do this. Let's just program our door switch to actually be a switchover for the set point. So let's see if that's going to work. I've never tried it, so this would be a very first for me. And I need to look on the parameter, which we're gonna start. ISP, it was here. Seconds, so it's parameter IISM. There you are, which is manual because it's on the keyboard, but let's just put it on the digital input 2, which is outdoor. And this, okay. And digital input 2, we need to configure that as well as IISM. Which is good. Let's try this. Let's switch this off. Okay, come back on. What's happening? Why are you stuck? Oh. Oh, there we go. Okay. So you are now with set point of minus 18. Yes, set point of 18. That's the first group. I want to switch to the second group of its set point. Boom, the light is on. Set point minus 22. It works. So the idea behind having two groups of set point, especially in restaurants, the way I understand it is during heavy use, which obviously the restaurant is open, the staff is making the food, they keep opening the door, so there's more duty on the fridge, then you want to lower the set point and increase the time interval of the defrost. So you're basically making the fridge work a bit harder. Then after the restaurant is closed, the unit won't be used, so you switch to the first group of set point, and it's also quite good for energy efficiency as well. The set point is lower. Yep, -18. So that's the idea behind it. I've never seen it in real life, but it's out there. Otherwise, this controller would not have this option. I think it's quite good, and it did impress me. However, just a quick one that I want to mention is, it does say on the controller manual that the controller can detect by itself if there's heavy use on the actual unit, and it will switch itself between the two groups of set points. So it won't be manual, and it won't be via a switch. It will just do it all by itself. Right. So a set point, I said earlier, is -22. What's important to know is just a quick FYI is the evaporator probe. It's reading -24. It will go on defrost. So if I force this on defrost, what am I doing? This is this one. It will go on defrost, and that's my defrost heater on. However, let's just say you go to site. Let's reset this. Let's just say you go to site and you find the cabinet iced up. One of the possible reasons would be the defrost probe being out of calibration. Because what we'll do is, if the defrost probe reads above the termination temperature, which is the parameter used to end the defrost, so we'll just set this as 13 degrees, 12 degrees, it will go on defrost, but it will not bring the defrost heaters. And we can try this. It goes on defrost, but it does not give power to the defrost heaters. And obviously, if it's a freezer, you need a source of heat to melt the ice that's built up on the coil. So yeah, in time, it will cause the evaporator to ice up. So the first thing that I would check is the defrost probe. What's it reading? So it's just gonna sit there, basically doing nothing. So let's just put that there, back to -24. Dun, 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 dun. Here we go. Let's reset this. Put that back. Let's go back to first group of set point. Okay, and now it will go on defrost. Yes, it's on defrost. Stopped everything, including my second compressor. All good. Now what would happen if I open the door? Nothing, but will it alarm? The door switch delay is set to 1 minute, so I don't want to wait. So which parameter was it? Let's quickly find out. It would be parameter Which one is it? Where are you? Oh, yeah. I was looking for it. Right. Yeah, so it will still alarm as door being open for too long, even though it's on defrost. Okay. Thanks for watching.